And so you're already developing a liquid engine?
Yes, in the process, designing for manufacture. A Regen liquid engine propulsion team are working very hard on this. We're very excited to see this come off, as it's a new field for Bristol SEDS to be looking at, and so it's very much been a learning curve. We're very grateful to everyone we spoke to at EuRoC 23 who gave us lots of information on the challenges that we might encounter, and we are encountering challenges. It's no mean feat to design a liquid engine. I'm trying to make that a bit of a reality.
You're probably going for a nitrous oxide ethanol engine?
Yes, we are. Although we might burn IPA in the UK competition because of availability. Propulsion team chose that because it's a bit of a standard across teams in Europe, and it seems to give us the thrust that we're looking for.
Fuels that's quite nice to work with in terms of it's not like hydrazine. You're not going to end up having to put like a 3 kilometre boundary around working on this engine, and also it's got some quite nice properties and decent specific impulse, so that's why we've gone down that route.
What can members learn from joining your team?
Possibly on a actually broader note, and maybe it links back to the last slide, part of our aims this year really are to put in the groundwork so that we've got good training for future years. So we don't want to make the mistake of when the team of us that have been working since COVID leave, there's then not the knowledge within the team to keep passing down. So really this question is actually quite topical for this year, because that is what we are currently working on, is building that up. From an aero point of view, we're looking at getting them to use rocketry analysis software such as OpenRocket and RocketPy, but then also looking into FEA and CFD, but then having the awareness of the difference between doing some hand calculations or using these tools and where each of those are valid and where you should be implementing them. So it's quite an exciting time really, because we're learning a lot of these tools from the aero side, as well as then teaching some of our 35 members those tools.
How do you design your rocket?
It's very iterative. It's definitely not a linear process. It's something that we've been coming to terms with since first year. It's very nice to think about, okay, well, if we work out, what apogee we want to reach, and then maybe what we want to make our rocket out of, and what propellant source we might want to use, and therefore what aerodynamics we need, and do we want to include a payload? And you think that those questions kind of come sequentially, and unfortunately they don't. You end up hopping between those questions, and as different things change. So the concept kind of comes from, what engineering challenges do we want to face? That's what gets us excited about rocketry, is that that it is a challenge, but then being sensible in choosing which of those challenges we actually take on. So that kind of defines our concept. You said concept to launch. There's a lot of steps within there, but that then comes with weighing up the how much money do we have. That often comes into it, because we're quite a small rocketry team. Doing a cost benefit analysis of the different elements of the rockets. Maybe this is, the propulsion team might be asking for something, but actually the launch vehicle team can't support that decision, and so we'll have a to and fro. So yeah, the process is it jumps around a lot, and it requires really good communication between our team members, which we're very lucky to have. And then we can get on to building some things and testing if they're structurally sound. Hopefully not testing to failure. That's our preference, because then that starts getting expensive. But then, so we, once we start getting into the build phase, then we are really looking at, is design safe, and is it holding up to the theoretical engineering choices that we made? And if we can say yes to enough of those safety choices, then that's when we're ready to launch and end up with the final product.
How do you measure the performance of your rocket?
We collect flight data from our flight computers, and if they match our simulations, that tells us what the performance of the rocket has been. We haven't had the chance to test a propulsion system yet, and I think that this consideration is going to be much more critical for us this year, because that will give us a much, when we talk performance for solid rockets, we're very much looking at the kind of hard flight data of the apogee achieved, and then did it perform the recovery operations at the altitudes that we're expecting? Whereas this year, looking at our propulsion system, and are we getting the thrust that we're expecting? Are we having the pressures and temperatures through our system that we're expecting? Those are some of the kind of concerns that we have this year, and that's the kind of data that we're looking to get.